Imagine a world where the air in our cities is clean and fresh. Where the only sound from a power plant is the whisper of the wind through a field of spinning turbines, or the quiet hum of sunlight being turned into electricity. This is the powerful dream of a 100% green energy future. It is a vision of a planet that runs entirely on energy from sources that never run out and do not pollute our atmosphere. It is an inspiring goal, and one that feels more urgent than ever. We see the effects of climate change on the news, we feel the heat of a warming planet, and we wonder if there is a better way. But then, we step back into our daily lives. We flip a switch and the light turns on, powered by a grid that, for most of the world, still relies heavily on fossil fuels like coal and natural gas. We drive cars that run on gasoline. We order products that are manufactured in factories burning these ancient, dirty fuels. This is our current reality. So, a huge question hangs in the air: can we really bridge this gap? Can we truly go from a world powered by stored sunlight from millions of years ago, which is what fossil fuels are, to a world powered by the fresh, daily gift of sunlight, wind, and water? The simple answer is that the goal is incredibly ambitious, but the journey is not only possible, it is already underway. The transition to green energy is not a simple light switch we can flip overnight. It is more like rebuilding the entire foundation of a skyscraper while everyone is still living and working inside it. We have to keep the lights on for 8 billion people while we slowly replace every wire, every power source, and every engine. In this video series, we will not just ask the question, but we will explore the incredible challenges and the breathtaking innovations that are shaping our path forward. We will look at the technologies that are leading the charge, the stubborn problems we still need to solve, and what a truly sustainable energy future might actually look like for all of us. When we think of green energy, two stars usually come to mind first: the sun and the wind. Solar and wind power are the poster children of the renewable revolution, and for good reason. They are abundant, clean, and becoming cheaper every single year. Let us break them down. Solar power works by capturing photons, tiny particles of light from the sun, and converting them into an electric current using panels made of special materials called semiconductors. It is a miraculous process that happens silently on rooftops and in massive solar farms in deserts around the world. Wind power operates on a simpler, grander scale. Giant turbines, like modern windmills, use the force of the wind to spin massive blades. This spinning motion drives a generator, which produces electricity. It is basically the same principle we have used for centuries, just supersized and hyper-efficient. Together, these two sources are leading the charge. The cost of solar panels has plummeted so dramatically that in many parts of the world, building a new solar farm is now cheaper than building a new coal or gas plant. The same is true for wind power. But why, then, are they not powering our entire world yet? This leads us to their greatest challenge: they are what we call intermittent. The sun does not always shine, and the wind does not always blow. The sun sets every night, and there can be calm, still days with very little wind. Our power grid, as it exists today, requires a perfect, instant balance. The amount of electricity being fed into the grid must always, at every second, match the amount of electricity we are using in our homes, factories, and cities. If that balance is lost, we get blackouts. So, while solar and wind are fantastic, they cannot be reliable 24/7 suppliers on their own without a little help. This fundamental issue of intermittency is the single biggest puzzle we need to solve to achieve a 100% green future. So, we have this incredible, free energy pouring down from the sun and blowing across our landscapes, but we cannot always use it the moment it is generated. The solution seems obvious: we need to save it for later. We need a giant, planet-sized battery. This is the great puzzle of the green energy transition, and solving it is the focus of some of the most exciting engineering on the planet. The most familiar form of energy storage is the lithium-ion battery, the same technology in your phone and electric car. Giant versions of these, called battery farms, are already being connected to grids to store solar power for use after sunset. They can react in milliseconds to keep the grid stable. But batteries are not the only answer. Another ingenious method is called pumped hydro storage. Here is how it works. When you have excess solar or wind power, you use that electricity to pump water from a lower reservoir to a higher one. Essentially, you are using electricity to lift water, storing the energy as gravitational potential energy. Then, when you need power, you release the water from the high reservoir, letting it flow down through turbines to generate electricity, just like a traditional hydroelectric dam. It is a simple, effective, and massive battery made of water and gravity. Scientists are also exploring more futuristic-sounding ideas, like using excess electricity to produce hydrogen gas from water, a process called electrolysis. This green hydrogen can then be stored in tanks and later burned in power plants to generate electricity, or used to fuel ships and planes, with only water as a byproduct. There is no single magic bullet. The future of energy storage will likely be a diverse mix of all these technologies: batteries for short-term needs, pumped hydro, and hydrogen for long-term and large-scale storage. Cracking the storage code is what will allow us to keep the lights on through calm, dark nights, turning solar and wind from intermittent helpers into the reliable backbone of our new energy system. While solar and wind get most of the attention, a truly robust 100% green grid will need a diverse team of players. Think of it like a sports team. You need more than just star strikers to win. You need a solid defense and reliable midfielders. One of these key players is geothermal energy. This technology uses the immense, endless heat from deep within the Earth itself. By drilling wells and tapping into underground reservoirs of hot water or rock, we can generate steam to spin turbines and create electricity. Unlike solar and wind, geothermal power is baseload power. It runs constantly, 24 hours a day, 365 days a year, regardless of the weather. It is a stable, incredibly reliable foundation. Another controversial but carbon-free source is nuclear power. Current nuclear plants split atoms of uranium in a process called fission, which releases a massive amount of heat to create steam and generate electricity. It produces no air pollution or greenhouse gases during operation. However, it comes with the challenges of radioactive waste and high costs. The future of nuclear may lie in advanced small modular reactors, which are designed to be safer and cheaper, and the distant dream of nuclear fusion, which aims to replicate the power of the sun on Earth. Then there is the humble giant, energy efficiency. The greenest and cheapest kilowatt-hour of electricity is the one we never have to generate in the first place. This means building smarter homes with better insulation, designing appliances that do the same job with far less power, and rethinking our cities and transportation to waste less energy. It is not as glamorous as a shiny new solar farm, but making our society more efficient is like plugging a leak in a bucket. It is the first and most important step that makes every other step easier and more effective. We have toured the technologies, from the soaring wind turbines to the deep geothermal wells. We have seen the incredible potential and the tough challenges. So, what is the final blueprint? Can we really go 100% green? The answer is not a simple yes or no, but a yes, if. Yes, we can power our civilization with 100% clean energy, if we are smart, determined, and global in our cooperation. The future grid will not rely on one single magic solution. It will be a smart, interconnected network, a symphony of different energy sources working in harmony. In this future, local solar panels on homes will generate power for the neighborhood. Vast wind farms offshore and in the plains will feed power to industrial centers. Geothermal and hydropower plants will provide the steady, always-on baseload power. And a massive, intelligent system of storage, from giant battery packs to hydrogen fuel cells to pumped hydro, will smooth out the bumps, ensuring power is available on demand. This smart grid will use advanced computing and sensors to balance supply and demand in real time, perhaps even telling your smart dishwasher to run when the sun is shining its brightest and energy is most abundant. The transition will be the largest industrial project in human history. It requires political will, significant investment, and a global effort. It means updating our laws, building new infrastructure, and sometimes making difficult choices about land use. But the reward is a planet that is healthier, with cleaner air and water, and a stable climate for future generations. The path to 100% green energy is not a single road, but a vast, interconnected web of many paths. The journey has already begun, and every new solar panel, every new wind turbine, and every battery installed is a step forward on that incredible path to a sustainable future. The power, quite literally, is in our hands.